Hello, my name is Gordon Sobering, Director of Costing and Engineering at Costmine Intelligence. Today, I will be talking about enhancing cost estimation and analysis using machine learning. The goal of the presentation, or what I hope you get out of this, is how Costmine's data set and cost models allow you to assess mining projects across the entire mine cycle. I'll also show how our benchmarking platform, Woody, quickly generates independent CAPEX and OPEX, as well as cost curves from publicly available mining documents, and how real mining projects compare using Woody. So why is machine learning becoming important in project evaluation and mining? First, mining projects continue to get increasingly complex, and the data is nonlinear. Cost models depend on complex interactions between geology, mineral reserves, resources, engineering, and mine operations. Machine learning models are well suited to learn from nonlinear data patterns rather than the usual rules of thumb that most of us use. Also, input values change so fast that static models become stale and outdated very quickly. Cost curves can swing dramatically with tariffs, commodity prices, steel, labor, and other items that change faster than users can revise their spreadsheets, while machine learning pipelines continually inject data and update estimates quickly. And finally, project evaluation is about more than just cash flow metrics. It's also about risk. Modern investment decisions require probabilistic thinking. What is the probability distribution of some of your unknowns, such as geology, engineering, commodity prices, and the construction schedule? Machine learning can be trained on an abundant amount of historical project data that's out there to predict future outcomes. As you get new data, models can be changed and updated quickly and show you how risk is affected. That's where Costmine comes in. We bring together mining data, cost models, and analytics in one place. We offer several solutions, but I'll focus on three that work closely together. Our bedrock is Mining Cost Service. This is the cost database and cost models that we have for mining, milling, reclamation, and cash flow. It's updated directly from our relationship with equipment manufacturers, mining dealers and suppliers, and mining companies themselves. SHERPA is the prefix of our cost estimating software that's based on engineering inputs with the mining cost service data, and again, for mining, milling, reclamation, and cash flows. Both of these feed into Woody, our web-based cost modeling platform that allows benchmarking and cost curves across global assets. Within Mining Cost Service are cost models with equipment, manpower, and supply needs. We have over 3,000 items in our database, including supply costs, explosives, fuel, mill reagents, mine tires, etc. We also have mine wages for the US and Canada, along with transportation costs, mining taxes, and more. We have a list of historic metal pricing for both base and precious metals. It goes back to the 1950s, along with cost indices specific to mining and milling. Instead of using a consumer price index for some old costs or a technical report, we have specific OPEX, CAPEX, and labor indices that you can use to escalate your costs. SHERPA, again, is our cost estimating software based on Mining Cost Service, which uses industry engineering and geological inputs to calculate CAPEX and OPEX across the entire mine cycle and is fully adjustable with its inputs. You can input the mineral reserve, production rate, dimensions of your ore body, depth below surface, and you can get capital and operating cost models which are shareable to your company and output detailed reports in Excel and PDF formats. And then finally, both again feed into Woody, our mine cost analysis platform. It allows you to benchmark independent CAPEX and OPEX cost profiles and cost curves from publicly available data and allows you to compare assets without having to build an individual cost model each time. Mining assets are updated daily, ranging from early exploration through technical studies, production, and reclamation. Woody is built for mining analysts, investors, corporate decision makers, and technical services teams who have their own cost models and would like to benchmark them and see how they fare. Why use machine learning in project evaluations? Pressure is rising to do more with less. We need to be accurate, timely, and transparent in our work. Using Woody is fast, allows you to evaluate multiple projects and scenarios quickly without sacrificing accuracy, provides consistent cost structures, standardized logic, comparable inputs across assets, and full auditability. You can trace your inputs and show how your cost is built up so it can be reviewed by internal or external audit groups. The current way of doing things is basically you with the internet and a very complex spreadsheet. You must collect all your inputs, source the technical reports, determine the commodity you want, find news releases and articles where you can gain any data. You must normalize your project data. A lot of your technical reports and news releases have a timestamp on them. You would have to bring them to a consistent cost basis, such as 2025. You have to take into account inflation, possible different currencies, and geographic locations for your mining projects. You need to vet your engineering and geologic inputs. Make sure, for example, the production rate is reasonable and that assumptions are not overly optimistic just to improve project economics. Then, you must manually do the benchmarking and comparing with current and past producers that are similarly in your bucket. And once you do one iteration, you have to do multiple iterations and get the sensitivity of your project. The disadvantages of this are, as mentioned earlier, manual data collection and maintaining a very complex spreadsheet, inconsistent cost categories between technical reports, and difficulty updating your spreadsheet when commodity or cost changes. In Woody's case, the assets are already in the database, and you need to define them by the stage of development. For example, PEA, pre-feasibility, etc. You also define what commodity you are looking at, the size of the operation, and geographically where it is located. SHERPA does the geologic and engineering support using first principles logic. Woody then calibrates your data, interprets it, and identifies any red flags within your selected peer group. Outputs are independent CAPEX and OPEX reports, cost curves, and any what-if scenarios that you want to evaluate. This next slide is a comparison of approximately 15 mining projects from the PEA to the feasibility level all over the world in the last few years. I've compared what Woody's OPEX is, which in this case is about on average 39% higher than what we're looking at. We use the same inputs of the mining companies based on technical reports, and the costs were in categories such as supplies, labor, power, equipment, operation, transportation, and smelting. You can see some of them are very close, but the larger gaps are red flags and should be reviewed in more detail for their input and transparency. Similarly, we did an analysis for capital costs using the same projects and technical reports. The CAPEX categories included equipment, surface and/or underground infrastructure, direct and indirect costs, and contingency. Off-site infrastructure was excluded from the technical reports. We don't include large civil project costs such as ports, rail, or transmission lines, so those were removed. Again, benchmarking highlights how scope changes, cost escalation, and productivity realities vary and require further review. This is a screenshot of Woody. You can see on the left, you can filter assets by commodity, stage of development, and geography, and below that, the sliding bars represent production over the life of mine, cash cost, mineral resources or reserves, internal rate of return, NPV, and payback period. You can use these to refine or expand your data set. The projects shown are copper projects at the pre-feasibility and feasibility level. The cost curve above represents their saleable metal on the x-axis and their C1 costs on the y-axis. I've overlaid the copper price so you can see the relationship between revenue and costs, at least from an OPEX perspective. Most of the data clusters closely together, except for this outlier on the right. Based on the contained metal, it appears to be a smaller ore body, but it shows significantly higher OPEX compared to the rest of the group. Key takeaways are that in mining project evaluation, Woody adds value without sacrificing the quality of your inputs, such as engineering and geology. It accelerates evaluation and comparison of mining projects, freeing users to focus on ranking assets, running what-if scenarios, and performing risk assessment. Mining Cost Service and SHERPA form the backbone of Woody. This allows gaps to be identified during evaluation before they become execution surprises. With traceable inputs, consistent cost categories, and reproducible outputs, you get full transparency throughout the process. Thanks for your time. If you'd like to explore how Woody fits into your evaluation process, feel free to reach out for a demo.